In this segment of the course, we're going to be reviewing conditionals and loops, two important structures in just about any programming language. Now, I'm sure you've seen conditionals and loops in whatever programming language you've used before, and in Java, they're really not at all different. So our conditionals are based on the old if statement and the old switch statement. So let's say we have an integer variable called age, and we assign that an initial value 37. So now we can test if age is greater than 18, then system out print line, you are eligible to vote. That's a simple if statement. And of course, what happens in here is this is evaluated, becomes either true or false. If it's true, we run what's in here. And if it's false, we don't. So in this case, we would output, you are eligible to vote. So let's go ahead and build this guy. So this is called conditionals. So we're going to run this as javac-d dot, and then it's called conditionals.java. And we're compiling, and we have compiled. So now we run it by using the fully qualified name, tv.learntoprogram.android course. It's about now that I wish I chose a shorter package name, .conditionals. Get tired of typing that. All right, so there's our result. You are eligible to vote, just as we expected. Now, this actually probably should be greater than or equal to if we're trying to emulate real life. Now, also, in order to vote in the U.S., you need to be a citizen. So we probably should also test to make sure that the user is a citizen. So in this case, I'm simply creating a Boolean variable, a true-false variable, and making sure that the user is a citizen. If it's true, we'll assume they are. If it's false, they're not. So in addition to the logical operator here, we have a compound operator to join these, and this is for AND. We use the ampersand twice. Again, pretty similar to most other programming languages that I know. And we test citizen. So now this will still evaluate as true because both of these conditions are true. Age is greater than or equal to 18, and citizen holds the value true. So if we go through the process again where we recompile, and then we execute the program on the Java virtual machine, the result is still you are eligible to vote. Now if I change this to false, now we're not going to see a result. It's going to compile, but running the program will yield no actual result. You can just see right there after the unable to find message about my path, that there is no result output. Now we could use a simple else statement here. And the simple else statement would happen if what's evaluated above in the if statement is false. So in this case, system out print line, you are ineligible to vote. So now, again, if we compile, because remember, citizen here was set to false, so this will evaluate as false, rendering the whole if statement false, we'll get the else result. All right, so we'll compile, and we'll run, and there it says you are ineligible to vote. So we get our else result. Now, one thing about Booleans, we can test them in conditionals just like this. We don't actually need to put equals equals true or equals equals false because Booleans are self-evaluating. They actually, when you evaluate them, turn into the true or false value that they hold. So in this case, this would evaluate as true and false because citizen holds the value false. I'm going to make it true again. We'll run this one more time, or we'll compile and run it one more time. There we go. And we run, and we get you are eligible to vote. And based on both of these values, we are eligible to vote. All right, so that's a simple conditional. Sometimes we also might want to do more complex conditionals with multiple else and if statements together. Let me show you how that would work. To facilitate that, I'm going to create a second file here. So I'm going to do a file and save as. And we're going to make this into the class complex conditionals.java. And of course, we've got to change the class declaration here so it matches the file name. And I'm going to get rid of everything except the declaration of the variable age. Now, what we're going to do is we're going to provide specific output about the user's age based on the age itself. So let's start with if age is less than 37. In that case, we'll output system out println. You are still young. I just made everyone who's younger than me young. Let's make that younger than 18. Let's do it this way. There we go. I like that better. You are still young. So if the age is less than 18, it'll say you are still young. I'm going to copy this so we can use it again instead of retyping it, just in the interest of time here. So we'll say else, and we'll join the else with another if. We'll say age less than 29. And so this would be if someone is between 18 and 29. We'll say something like, these are the years you should be having fun. I don't know if that's actually true. If you happen to be in that age group, I hope you are having fun. And let's do age less than 39. This is the group that I fit into. System out println. Had that in the buffer. I should have just hit Command V versus retyping it. Anyway, time to get serious about your career. Sounds like very motherly advice we're giving here. Else if age is less than 49. Maybe we'll just do one more after this. System. Let's use there we go. So if you're less than 49, if you're in your 40s, let's say these are your money making years. Else if you're less than 59, let's say I hope you are preparing for retirement, although you should be doing that much earlier than that age, I think. I'm just going to work till I die. That's my retirement plan. And then finally, we'll just do a final else, meaning that age doesn't fit into any of the previous categories. So else, we'll just say you are still young. We'll just say you are officially old. All right. So with age 37, what's going to happen is it's going to evaluate this first if statement. It's going to say, okay, that's false. So it's going to go to this next if, age less than 29. That's also going to evaluate as false. So we get to this next else, and this is going to be true. And it'll run the system out println on line 17. And then it's going to stop evaluating anything else. Because remember, this is an else statement, and we only evaluate we only continue evaluating if, in fact, the previous if was false. In this case, it's true, so we're done right here. All right, let's give this a try. We'll bring up my handy-dandy terminal here, and this time we're compiling complex conditionals.java. Oops, looks like I made an error here. Complex conditionals line 29. Let's see if we can figure out what it is. Yep, we're missing a bracket for the end of main. All right. And see, it tells you right where the error is. So when you make one, you can generally look in that area. Sometimes it won't be exactly right because what it is it's where the browser kind of stopped. Excuse me, the browser, where the virtual machine stopped parsing the code, or the compiler in this case stopped parsing the code on line 29 because it couldn't figure out what I was doing. So usually if you look around there, that's where you'll find the error. But in any case, now if we go back, it should compile just fine, and it does. So now we've got to run this again with the fully qualified name, tv.learn-to-program Android course.complex conditionals. All right, time to get serious about your career, which is the expected result based on the age we put in here. If we change the age, we'll just change it once. Let's say 60. So now, based on an age of 60, we should get a different result. We compile again, and we run the program, you are officially old. So those are complex conditionals. Now there's one more type of conditional that I want to spend some time on, and that's a switch. A switch is an older structure, but still one that can be very useful for testing multiple conditions. So again, what I'm going to do here, we'll go ahead and minimize our command line. I'm going to rename this source file, and we'll call this switch.java. I'll rename the class, and we'll get rid of all of this. All of this setup, by the way, is a lot easier once we start using the Eclipse IDE for Android. But since we're not yet using that, we got to do all this by hand. Eclipse got a bunch of templates for this stuff to make your life easier. All right, so let's say here that we are have some type of letter grade that a student earns. So let's say char grade equals A. So a char being a single character variable, and the student got an A. So what we'll do is we'll switch based on that grade, and we'll provide a result or some output based on the different grade values that grade could have. So the first case is grade equals A. And if that's the case, then what we're going to do, oops, that shouldn't be quotes, that should be a colon here, is system out print line. And A is outstanding if I can type, outstanding achievement. And a lot of people forget the break. Each case, except the last one, needs a break. And even if you put one in the last case, it's not tragic either. So this is case where grade equals B. System out print line above average achievement. And let's again not forget our break. Case C. System, oops, don't forget that. There we go. C is average achievement. And of course, breaks. You're starting to see the pattern here. Should be pretty obvious. Case D, and again, the switch case break statement doesn't differ a whole lot from language to language. So you should be familiar with this if you've used this before in PHP or a .NET language, whatever language you're coming to Android development from. All right, so I had a middle school teacher who said D is for dumb, but that's kind of mean. So let's do D, low passing score, break, and then case of the unfortunate F, and that would be failing grade. And let's just put one in case that none of those are the actual case, so to speak, where grade doesn't equal A, B, C, or D. So we'll put here system out print line grade not recognized. And we don't need a break with the default case or the last case, whatever that may be. All right, so what we're going to do next is we're going to compile this. So this is called switch.java. So javac-d dot switch.java. Oops, looks like I've got an error there by the break. Let's see if we can find that. Oops, there it is. I see it on line 22. I used a colon instead of a semicolon for the break. Maybe you found that before I didn't even looking at it the whole time, wondering when I was going to correct it. Well, I just did. All right, so now I'm going to hit the up arrow, so I don't have to retype my statement. And no errors this time, so did that right. So Java. And then we've got to do the fully qualified name. So tv.learn-to-program.android.switch. switch. All right. And did I do that right? Let's see here. Oops, it's Android course. That's 2 typos in a row here. So Android course, that's why we couldn't find it. Dot switch, and we get outstanding achievement, which I apparently spelled wrong. All right, so now I want to see what would happen if I switch this grade to a lowercase version of the grade. So of course we're going to have to recompile, and we're going to have to run it again. And we get grade not recognized. It ran the default case. And that's because the lowercase c doesn't automatically match the capital C. So in order to have that match, what we're going to have to do is do multiple case statements for each outcome. So in case they put a lowercase a, I'm going to add the case here like that. And I'm going to do that for all of these. Just takes a second. So now we're dealing with multiple cases in which this action below here will take place. And case F. Okay. I think that'll do the trick. So now remember, the grade is a lowercase c. So if this works, we should see system out print line average achievement. All right, we're going to compile this program one last time. And let's run it. And we get average achievement because the lowercase c matched the second case here on line 20 and then resulted on what we have on line 21 being output. All right, so those are the conditionals. Let's turn our attention to reviewing the kinds of loops that are available in Java. All right, and through the magic of video editing, there is our blank loops file. So in here, we're going to write a couple of different loops. The first loop, again, same in every language, so you should be familiar with this, would be a while loop. So let's say we want to count from 0 to 100. We're going to use a while loop. So we're going to say while x is less than 101. We're just going to system out print line the value x. And then we'll increment x. That's all we need. That's going to do the loop, because what's going to happen is first time through x is 0. And it's going to say 0 is less than 101. So as long as this evaluates as true, we'll execute what's in here. We'll add 1 to x. 1 is less than 101. So we'll keep going and looping through, or what's known as iterating. It's one of my favorite computer science words, iterating. Fun to say. So until we get to 101, then 101 is not less than 101, so we'll stop iterating. All right, let's try this in the command line. So let's see here. This is loops.java, so I'm going to go ahead and run loops. And no errors, good. So now we can use the Java virtual machine. Once again, I wish I chose a shorter package name. And there we go. We stop at 100. And if we scroll up here, somewhere we started counting at 0. All right, so that worked just fine. That's a while loop. Now, there's another similar type of loop called a do-while loop. Now, all a do-while loop does that a while loop doesn't is it backloads this condition. So a do-while loop is guaranteed to iterate at least once because it doesn't evaluate the condition till the end. So let's say y is less than 250. And we'll have this loop count from 0 to 250 by 5s. So system out print line y and y plus equals 5. It's another way of saying y equals y plus 5. And just for now, I'm going to comment that out with a multi-line comment. So this way we only run the first loop, not the second. All right, I think that's correct. Let's go ahead and try it. So I'm going to go ahead and compile all over again. Happens very quickly the second time. And let's see here. Oh, missing my semicolon after the while statement. Perfect. And let's count. And we stop at 245 because I used 250 here. If I had said 251, then we would have gotten all the way through 250. Now, again, a do while loop is guaranteed to iterate at least once. Watch this. I'm going to start with a condition which makes this initially false, right? Because this will add 5, it'll become 305, and 305 is not less than 251. With the do while loop, however, we will still get the first iteration of output. So you want to use a do while loop when you want to guarantee your loop will iterate at least once. Now, finally, there's the for loop. And this is actually my favorite loop. I don't know if a lot of people have a favorite loop. I'm pretty sure my mother doesn't have a favorite loop. But my favorite loop is the for loop. And that's because it's so compact. We have 3 arguments in the for loop. The first is initialization. So let's say we're counting integers, and we're starting at 100. So int z equals 100. And then is the continuation condition. We'll continue counting while this is true. So z is greater than 0. And this is how we count. So z equals z minus 5. So the way I've set up this loop is we're going to count backwards from 100 by 5s, stopping or continuing to count while z is greater than 0. Let's make that -1. This way we actually see the 0. All right, so now we'll do the system out print line, the value z, and that's all we need to do there because our math, our counting, is taken care of by the third condition of the for loop. Okay, so let's go ahead and compile one more time. Loops.java is compiled, and we run it, and there we go. 100 down to 0 by 5s. So in this video, we went ahead and reviewed both conditionals and loops. You should be familiar with those from whatever language you're coming from, but now you see how they work in Java, and of course, in turn, how they'll work in Android.